हेलो, आवाज क्लियर है? वॉइस कंफर्मेशन दीजिए बेटा, प्लीज गिव द वॉइस कंफर्मेशन। नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार, फैकल्टी ऑफ मेजरमेंट्स इंस्ट्रूमेंटेशन। मैं आप सब लोग को स्वागत कर रहा हूं लेक्चर नंबर 2 पर। लेक्चर नंबर 2 पर स्वागत कर रहा हूं। कल हमने पीएमएमसी एंड मूविंग एंड डिस्कस किया है। आज हम डिस्कस करने वाला है डायनामोमीटर एंड एनर्जी मीटर। जितने लोग लाइव में है जल्दी से जल्दी ज्वाइन करो बेटा। जितने लोग लाइव में है फटाफट ज्वाइन करो, हम सेशन स्टार्ट करेंगे। यस, क्लियर, परफेक्ट। चलो, लेट्स स्टार्ट द सेशन। चलो, in measuring instruments lecture number 2 we are going to discuss about the dynamometer. So what is dynamometer, how it works? So we are going to start with the introduction of dynamometer. चलो सर, थोड़ा एको है, आवाज गूंज रही है। ओके, अभी क्लियर है आवाज? रोहन जी, अभी आवाज क्लियर है? ओके, सी इफ यू सी द कंस्ट्रक्शन ऑफ dynamometer, the basic construction of dynamometer, it is having two fixed coils. So this is a fixed coil 1. So this is the load. Okay, and I'm going to take the moving coil. So there is a spindle like this. So there is a small moving coil like this. Which is going to deflect. This is a pointer. Okay, There are two springs. So it is having fixed coil 1, fixed coil 2. It is a moving coil. It is also called the current coil. This is also called current coil. This is called the potential coil or the pressure coil. We call it as pressure coil. So when it comes to the dynamometer, basically dynamometer expression, I am not going for the derivation. Deflection of the dynamometer, if you see, deflection torque is equal to I square dm by d theta, controlling torque is equal to kc theta. So at steady state, deflection torque is equal to controlling torque. So I square dm by d theta is equal to kc theta. So theta is equal to I square by kc into dm by d theta. So theta is proportional to I square. So it is suitable for both AC as well as DC current measurements. Okay. Is it clear? So if you check the dynamometer ammeter graph, uniform or non-uniform? Dynamometer ammeter graph, uniform or non-uniform? So whenever this I square is like this, so if you take the scale, so the scale will be like, for a smaller currents and the deflection, if you check, going like this. So first initially there is a crowded values, then some linear values, then some spacious values. So this is crowd or cramped, this is linear, this is spacious. So scale is non-uniform. Please note down, dynamometer ammeter scale is non-uniform. Similarly, I can take dynamometer voltmeter. So I square TD is equal to TC. I square dm by d theta is equal to kc theta. So this is v square by r square dm by d theta is equal to kc theta. So theta is proportional to v square. So that means if you draw the scale again for voltage and T, theta, again the graph is like this. This is cramped, this is linear, this is spacious. So theta is proportional to v square, non-uniform. So both dynamometer ammeter and dynamometer voltmeter, both are non-uniform. Please make a note of all these things. I will inquire with the admin team. My schedule manager को पूछता हूँ क्या हो गया notes, why notes is not pasted. I will ask them. Please make a note of these points. Have you noted? Yeah. Yes. It is also called as EMMC, electromagnet moving coil. This is also called as EMMC, electromagnet moving coil. The other name for the dynamometer, electromagnet moving coil. Why? Because there is two electromagnets and one moving coil. Okay. पहले क्लास पर फोकस करो, बार बार नोट्स पूछते, पीडब्ल्यू ऐप पर अवेलेबल है. उसके बाद बच्चों को भी बहुत तकलीफ हो रहा है, सब चाहिए. यू कैन सर्च इन द ऐप. चलो. So now if you say actually deflection torque formula I square dm by d theta, but practically speaking this I square is not I square, this is I1 I2, current passing through the potential coil, current passing through the current coil, current passing through the current coil and current passing through the potential coil. So what is I1? I1 is the current passing through the fixed coil, that is Im1 sin omega t. I2 current passing through the potential coil, which is Im2. Definitely potential coil constructionally different feature, so it is having some phase shift, omega t minus phi. So comparatively current passing through the current coil, current passing through the potential coil, they will be having a phase shift. So now if you do the average torque for this, so if you do the average torque for this, 1 by t integration of 0 to t td into dt, and if you simplify, what I am going to get, see here, 1 by t 0 to t td is equal to I1 I2 dm by d theta into dt. So 1 by t integration of 0 to t, this is Im1 sin omega t, this is Im2 sin omega t minus phi into dm by d theta and dt. It's a big derivation. I'm not going for the derivation, my dear. I'm just taking the final expression. So finally what we are going to get, when you simplify this, When you simplify this, the average torque expression we are going to get as ICC, IPC, current passing through the moving coil or current passing the potential coil, into cos phi into dm by d theta. So this is the expression. Why? Because what is the basic purpose of dynamometer? Yeah. What is the basic purpose of dynamometer? Dynamometer also can be used as ammeter. Dynamometer also can be used as a voltmeter. Dynamometer also can be used as a power measurement. So when it comes to the ammeter, voltmeter, it is non-uniform, but when it comes to the power measurement, it is uniform. So how we can write that uniform? See here. So this one I can write ICC VPC by resistance of the pressure coil cos phi dm by d theta. So ICC VPC 1 by R. So we got the power formula. This is what our power formula, 1 by R dm by d theta. So this is our average torque, which is nothing but our average power. Is it clear? So this is the deflection torque. So this is a controlling torque. Controlling torque. So at steady state, if you equal these two, ICC, VPC, cos phi 1 by R dm by d theta is equal to kc theta. So theta is equal to ICC VPC cos phi 1 by R kc into dm by d theta. If you take this as some constant, so theta is proportional to ICC VPC cos phi, which is nothing but average power. So this is the average power. So if you take the scale, so dynamometer, wattmeter, ammeter, voltmeter non-uniform, but if you check the dynamometer, wattmeter, so what I am going to get, theta is proportional to ICC VPC cos phi. Theta is proportional to ICC VPC cos phi, so which is proportional to the average power. So now if I draw the scale, so if I take the P average and the theta here, the scale is going to be what? The scale is going to be uniform scale. So what is the conclusion? Dynamometer, ammeter non-uniform, dynamometer, voltmeter non-uniform, dynamometer, wattmeter uniform. That's the reason why dynamometer is suitable for power measurement. Is it clear? Make a note of all these things, my dear. Take some time. Noted? Yes. Now let us talk about some errors. Okay, error due to connection. So generally, what are the geometrical features of the coils? So if you see the dynamometer, fixed coil and the moving coil, how they will look like? If you see the connections, if you see the dynamometer, wattmeter, if you see the fixed coil is basically thick. This is the fixed coil. This is a shorter length. Fixed coil, which is also called as current coil, more thick in size, shorter in length. The reason is what? Thick in size means area is more. So this is the area of cross section. This area is more. Length is less. So then what happens? R is equal to rho L by A. Area is more, length is less. Obviously resistance will be less. So resistance of the current coil will be less. So that is a point you have to understand. Resistance of the current coil will be less. So when the resistance of the current coil is less, obviously current passing through that coil will be more. So current coil, as the name indicates, it would have more current to travel. Next, when it comes to potential coil is like this. Pressure coil or potential coil, which is called the moving coil. Thin in size, longer in length. So the resistance of the potential coil will be more. Please make a note of these points. Noted? Dynamometer, wattmeter connections, fixed coil, pressure coil, have you noted? Done? Yeah. Now let us go for the connections. Let us go for the connection. Where the potential coil is connected, based upon, then we are going to take two connections. See here. So this is our current coil. Even though two fixed coils, two current coils in the dynamometer, but we are taking as one current coil. Okay, so this is our current coil, which is thicker. Okay, so this is our load. Next, this is our potential coil or moving coil. So where you are connecting this potential coil? Based on that, suppose if you are connecting here, so this is mains, single phase supply. So this is our potential coil. Actually we should keep a resistor here. So this is the resistance of the pressure coil, which is high. So this is a load. This is one connection. So this is a current coil. The other connection here is same to same. So this is a current coil. So this is our load. So this is our pressure coil. So this is our resistance of the pressure coil. This is our current coil. The connection of this can be connected at the load side. This is also correct. Patience होना चाहिए भैया diagrams को. So this is what we call a single phase. Can anybody tell me what are these connection names? So this is a pressure coil, this is a current coil. So this is a load. What are these connections? Yeah. So pressure coil is connected at the main side. So these are mains. So pressure coil is connected at the main side. So that side is called as MC connection. Here the pressure coil is connected the load side. So it is called LC connection. MC connection, LC connection. So this is mains connected. This is load connected. So please note down. Can you tell me what is the difference between these two and what can be the error? Is there any error possibility? Tell me. MC connection, LC connection, any possibility of error? What is the error possibility? Please note down and tell me. रिस्पॉन्स दीजिए भैया. आज थोड़ा हेल्थ अच्छा नहीं है, फिर भी मैं क्लास ले रहा हूँ, यूट्यूब क्लास. नर्वस है, बॉडी पूरा वीक हो गया, फिर भी मैं क्लास ले रहा हूँ. थोड़ा आपसे थोड़ा मुझे रिस्पॉन्स चाहिए, मुझे रिस्पॉन्स चाहिए. In LC connection, MC connection, what is the difference? What type of error we are going to get? Door. सोच के बताइए बेटा, एरर ड्यू टू एमसी कनेक्शन क्या होता है, एरर ड्यू टू एलसी कनेक्शन क्या होता है? See here. Yeah. See here. Let me write error due to MC connection. So what is MC connection? This is the current coil, this is the load, this is a pressure coil, this is the resistance, this is a single phase AC supply, single phase means, so this is the MC connection. So if you check this as a load, so this is VL, and जो करंट यहाँ से आ रहा है, सेम करंट विल ट्रैवल हियर, ICC, and this is the VPC between this and this. So the true value VL IL cos phi, power consumed by the load, this is the true value. जो लोड है ना, लोड कितना कंज्यूम करता है पावर, दैट इज अ ट्रू वैल्यू. am I right? जो लोड कितना कंज्यूम करता है, दैट इज अ ट्रू पावर. बट इन एडिशन टू दिस, we are having this resistance of the current coil and this current passing through current coil, so this power also will come. So now, so together this we have to consider. So measurement value is equal to true value plus power consumed by the current coil. So what is the power consumed by the current coil? That is current passing through the current coil, resistance of the current coil. So that is the measurement value. So what is the error? Error in MC connection is I square or CC. So please make a note of this point. Okay, ma? So that is the error. Percentage error means measurement value by true value into 100. So generally हमको error कम होना है. So this particular connection is where suitable. Error less होना है. अगर error कम होना है तो हमको कहाँ यूज करता है वो? Yes. So error कम होना है बोलो तो क्या है? ICC कम होना है. ICC when it will be come, when it will be less. So when the load is more, definitely ICC will be less. So what we can write? Suitable for high resistive loads. High resistive loads it is suitable, and for smaller load current also it is suitable. Please note down. Please note down most expected question. Similarly, please try for LC connection. Load side connection, you please try and tell me what is the error due to LC connection. Answer please. Error due to LC connection. Yeah. VL IL cos phi, whereas measurement value is true value plus power consumed by the pressure coil. Power consumed by the pressure coil is V square by R. Am I right? So what is the error? So if you are expecting error to be less, the VPC must be less. VPC must be less means IPC also less. IPC is less means these are IPC. So this is I, this is IL. So VPC कम होना है बोले तो IPC कम होना है. That means load current ज़्यादा होना है. For higher load currents or smaller resistive loads. That's it. Yes. Perfect. Note down. Have you done? Is it completed? Have you taken? Yeah. If you're done, please go for this problem. Answer please. Yeah. So it is what connection? MC कनेक्शन, क्योंकि मेन साइड कनेक्टेड है. Okay, so this is the VL, this is the IL. So what is the true power? VL IL cos phi. So 200 into 20, unity power factor 1, so 4000 watts. मेजरमेंट वैल्यू क्या होगा? ट्रू वैल्यू प्लस I square or CC. This is 4000. Current passing the current coil 20 square. This is 0.02. 2 by 100, 400. 8, 4008 watts. So percentage error पूछ रहे. Measurement value minus true value by true value into 100. Measurement value कितना है? 4008 minus 4000 divided by 4000 into 100. Plus आएगा. So plus is most important. 0.2% more. Answer this. So what is the true value? True value is VL IL cos phi 30 into 25 0.8 कितना आएगा 750 into 0.8 750 600 watts. Measurement value, true value by power consumed by the pressure coil. This is 600 plus V square by resistance, that is same voltage रहेगा 30 square divided by 1000, 900 by 1000, 0.9, 900 by 1000, 600.9, 600.9. So मेजरमेंट वैल्यू कितना है 600.9, ट्रू वैल्यू 600 by 600 into 100 plus 0.15. Please note down, take a break. Sorry my dear, I'm stopping the class here, don't worry, because I'm not feeling well. So I'm feeling very discomfort in my body. I tried my level best, but it's not happening. If possible, I will take tomorrow. Okay, I'm stopping the session for today. Tomorrow class we'll discuss the 2 wattmeter method, okay, and energy meter. Enough for today. Okay. डिस्कम्फर्ट है बॉडी में.